We'll quiz here and then we'll start our sequences and series, which is the last part of the chapter. So, here's our review sheet. Everybody's in uniform, got on lanyards, appropriate shirts. And probably are going to need another sheet of paper because when I typed this up, I didn't space it out. So you might want to do this on a sheet of paper. I don't care, it doesn't matter. Whatever works for you. But it is kind of going to be. All right. So let's look at the first problem. And let's figure out what is happening. There are 4 boys and 6 girls in the group. Okay, so that's our basis. 6 girls. How many ways can they be arranged in a row? You shouldn't be pausing. This is easy. How many kids are there?
10.
How many ways can you arrange 10 things in a row?
9.
10 factorial. So 10 things in a row is 10 factorial. Guys, that is one of the fundamental things. You need to know when you arrange in a row, it's n factorial. Now, what about when we arrange them in a circle? 9 factorial. Now, on quiz day, you're going to work these out for me, but I don't want to waste class time. You all know how to get 10 factorial on your calculator, so you'll do
It's a
that.
calculator quiz?
Yes, yes, you're going to need your calculator to answer the question, right?
Wow, yeah.
All right.
I got him in her problem.
This is supposed to say in how many ways can they be arranged in a row if all the boys must sit together? Right, now think about that for a minute. I don't care where these guys sit, but these guys all have to sit together. So I am tying a rubber band around these boys. So when I go to arrange them now, how many things am I really arranging? 7. I got my 6 girls and my bundle of boys, my 1 big boy. So that's 7 things that I'm arranging. But when I tied that rubber band around those boys, just the boys, they could have been arranged themselves in 4 factorial ways. Right? Boy A, B, C, D, or C, D, A, B, or whatever, right? 4 factorial arrangements for the boys. So 6 girls, a bundle of boys, that's 7. And then the bundle itself is 4. All right. How many ways with a girl on each end? So you've got, think about it, you got 10 kids, right? 10 seats. But you have to put a girl on this end. How many choices do you have for this first seat down here? Don't you have 6 choices? I gotta pick a girl. I have 6 choices. And what about for the other end of the row? I have to have a girl on each end. What about the other end? 5, because I put 1 down there, so there's only 5 left. Now, how many seats are there left to fill here in the middle? 8? Do I care who sits where? How many ways can I arrange the remaining 8 people?
8 factorial.
8 factorial.
So the answer is just 8 factorial?
It's 6 times 5 times 8 factorial.
38. Did you multiply 30 times 8?
8 factorial. Yes. Now, if I choose 4 students, what is the probability that I'll get exactly 1 boy? Now, this is a probability question. So these have been, how many ways can I do something? So these are all big numbers. The probability is going to be a small number because it's a fraction. What's going to go in the denominator? What what is the probability that if I choose 4 students, I'll get exactly 1 boy? So what's gonna go in the bottom? Total. How many total kids are there? 10. How many total am I picking?
4.
So the bottom is 10C4. That's your total. That's every single possible combination of 4 kids. Now, what do I want to happen?
4C.
I want to get 1 boy and 3 girls. So, how many boys are there? 4, and I want 1. And how many girls are there? 6, and I want 3. So when I type that in on my calculator, I will get some kind of a decimal. And that will be the answer.
Is it a buzz?
What is the probability that I'll get at least 1 boy? Okay, you see the difference in the problem? This was exactly 1 boy. What does at least 1 boy mean? I could get 1 or 2, oh good grief, or 3 or 4 boys. Now, I already did this one. This right here is 1 boy. Could I structure 2 boys basically the same way? 2 boys, 2 girls. And then 3 boys, 1 girl, 4 boys, no girls. I could do that. And if I did that, I'd have this decimal, and this decimal, and this decimal, and this decimal, and what would I do with them? Add them up. Because it's this or this or this. I'd add them up. That is an option. 100% that will work. It might be faster though to do what? What I don't want. So if you think about this, what is the only situation that I don't want?
0 boys.
So 0 boys. That's the only one I don't want. So what if I took 1 minus no boys? Wouldn't that give me what I do want? So what does no boys look like? Well, no boys would be all girls. So 6C4, and then if you wanted to say 4C0, you can. 4 boys, pick 0. That's just 1, that number is 1. You don't have to include it. And of course, divided by 10C4 because that's the total. And then we're going to take 1 minus that, and that will give us our answer. Lucy?
Why are you doing 64? Are you thinking like, I'm confused on why you did 64.
As opposed to what?
Well, would you not do 10C6, picking 6 girls out of all 10?
Okay, wait. What does the question say? How many students am I choosing, Lucy?
6.
How many am I choosing?
Oh, 4.
And they have to come from the girls. How many girls do I have to choose from?
6.
64.
Yeah. They go really well with the high stakes.
So this answer will be exactly the same as if you did it this. Either one is okay. But this is a lot faster. Alright, and finally, if I choose 4 students, what's the probability that I'll get more girls than boys? Okay, so what does that mean? More girls than boys. What do I have to get?
3 girls and 1 boy.
I have to get 3 girls, 1 boy, or I have to get
4 girls.
4
and
girls.
0.
Now, I just did the 4 girls right there, so that would be 6C4, 4C0 over 10C4. Or, what would 3 girls and 1 boy look like? 6C3 times 4C1. Now, a little hint, and a problem like all of these here that we've been doing, the denominator has been 10C4, right? It's going to be 10C4 as long as I'm picking 4 kids. So it might be easier, instead of doing each fraction individually, it might be easier to go ahead and add the numerators and then divide once by the common denominator. Right? See what I'm saying? That might save you some typing time. Doesn't matter, it's up to you. All right, if Sabrina has math tomorrow, there's an 87% chance that she'll do her homework. If she doesn't have math tomorrow, there is a 71% chance that she'll do her homework. If the probability that she'll have math tomorrow is 80%, find the probability that she will do her homework. Whoa, that's a lot of words. What are you thinking strategy-wise? I'm not thinking this, because I'm not picking, I don't like have a clump of picking something. This sounds like a conditional thing. I got math or I don't have math, I'm gonna do homework or not do homework. So, I have math, and I have no math. And then I either do homework or no homework. Alright, so let's stick the probabilities in there. If she has math, there's an 87% chance, so that probability is 0.87, which automatically means this one is 0.13. If she doesn't have math, there's a 71% chance, so this is 0.29. The probability she has math tomorrow is 80%. Find the probability that she will do her homework. So, keep in mind, there are two tracks through which she's gonna do homework. She's gonna have math and do homework. So, have math and do homework. Or, she's not gonna have math and do homework. Does everybody get that? So you're gonna type those, add them up, and that's gonna be the answer to the question. In how many ways can the letters of I miss you already be arranged? How do we do this? So before I do anything, what do? Count them up. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. I got 15. Did I count wrong? 15? So I start with 15 factorial. No matter what, start with your total items. In this case, it's letters. It's frequently letters on this kind of problem, but regardless of duplicates, doesn't matter, count up the total. How many do you have? In this case, 15. Now we go through and we figure out what we have duplicated. Alright, so it looks like I have 2 S's. What else do I have? 2 I's. 2 A's. 2 Y's. Oh my, there's a lot going on here. Is that it? Now, in this case, again, we're all about saving time. What's 2 factorial equal? Now, that's the only number that's true for, right? 3 factorial is not true. But 2 factorial is 2 times 1, so it's 2. So basically in the denominator here, we have 2 times 2 times 2 times 2, 16. So you could just type 15 factorial divided by 16 to save yourself some time. If these are other numbers, just remember, if you're dividing by more than 1, you gotta put them in parentheses, right? Or you won't get the right answer. All right, without a calculator, showing all work, what's 10p3? Well, you can't do this unless you have a formula. What's the permutation formula? Tess? 10 factorial over 10 minus 3, 7 factorial. That's exactly right. That's the formula for permutations. It's how many you have, factorial, divided by the difference. So if I'm doing this without a calculator, I remember what 10 factorial means and what 7 factorial means. And what do I notice? It's all going to cancel. So I'm left with 8 times 9 times 10, which is 720. Easy, easy, easy. Now what about 12C8? What is 12C8? That's 12 factorial over 4 factorial, 8 factorial. The combinations do exactly what the permutations do, except you also have this number in the denominator. You have to divide out this number. So that would be 12, 11, 10, 9, and then that's gone. But I still have 4, 3, 2, 1. So that kills the 12. This will take care of the 10. Pardon the 10. So it looks like I have 55 times 9. Is that 495? Double check that now. So there we go, without a calculator, 495. What is the probability of drawing both the king and queen of spades if you draw 4 cards from a standard deck? If stop, probability, denominator, what's the denominator? 4 cards from a standard deck. 52C4, gotta have the big number first. This is how many we're picking from. This is how many we're picking. Now, my numerator is what I want. So what do I want? I want the king of spades. How many kings of spades are there? 1C1. There's 1 and I want it. And same with the queen. But I'm not done. Because how many cards are supposed to be in my hand? 4. Where are the other 2 coming from? I've got my queen of spades and my king of spades. Where are the other 2 coming from? 50C2. No, not 50C4, 50C2. I'm only picking 2 more cards. And they can be anything. The king and queen are already out. 50 left, pick 2. How many ways can 10 identical blue beads, 6 different green beads, 4 different yellow beads be arranged on a necklace with a clasp? So the 10 blues are identical, the 6 greens are different, and the 4 yellows are different. Okay, just arranging them on a necklace with a clasp. Well, first of all, how many beads are there? 20. But there's a clasp, so that's basically 21 things, right? 21 things. But I'm arranging them in a circle, so that drops it down to 20. So I'm starting with 20 factorial.
Why does it drop it down one?
It's a circle, just like the people in a circle. First problem we did, when we arranged it in a circle.
Yeah. Why did it drop it down one?
So 20 beads in a circle would be 19 factorial, but I got a clasp in there, so that's like another bead. So now it's 21 things dropping down to 20. Okay, am I done?
Divide by 10.
I have to divide by 10 factorial for sure, because that's just like having 2 M's in the word. You have to divide by whatever's the same.
6 and 4.
And then there's one more. It's a handheld circular arrangement. I can look at it from both sides. So what do we do?
2.
Divide by 2. It's called reflections. We only do it with necklaces, bracelets, and keychains. Think if I take my necklace off, when I look at it, this little pin right here is on the left, but when you look at it, that pin is on the right. So if I do a picture of it on the blackboard, it would look different, but is it really different? No, we're looking at it from the same side. That is only done with necklaces, bracelets, and keychains. That's it, that's all it's done with. When you do that, be careful, make sure that's in the denominator, or in the parentheses we're taking it. All right, 2x minus y to the 5th. You go lots of room for this one. When I expand 2x minus y to the fifth, I need my coefficients to get started. And where are those coefficients coming from? Come on guys, we don't have all period to review. I'm gonna cut this off because we gotta get going here. Where did those coefficients come from? The fifth row of Pascal's triangle. Which I have memorized because I do this job, this is my job. You don't necessarily have that memorized, but you know how to build the triangle, you can build it out. It's the fifth row of the triangle. Next to each of those numbers is gonna go in 2x and a negative 3y. Because those are the parts of my binomial. They might start running together, so put pluses between them to separate each term. And what's the only piece left? I need the exponent. So just think about foiling this. If you wrote this out 5 times and started foiling, wouldn't the power on your x be 5 after you multiplied them all together? So this is 5, and then they decrease. And the y's do the same thing, but in the other direction. Now, essentially, the problem is finished. Except for simplifying each term. So I'm not gonna simplify each term, I'm gonna simplify a couple of them. This guy right here, remember, anything to the 0 power is 1. So he really isn't, don't let him mess you up, he's just 1. This first term then is 32x to the 5th. Now, let's look at this term right here. We have to simplify all of them. All that is multiplied. I know there's a negative in there. Deal with that, but don't put it in the middle of the term. It's not a subtraction. This is all multiplied. So I am multiplying 10 times 4 times negative 27. What is that? Negative, was that right? Negative 1080. And then I would have x squared y cubed. So that is that term. If you write 40x squared minus 27y cubed, which I see all the time, it's wrong. This is not a subtraction, this is a multiplication. So you will have to do that with each term. Simplify each term in that exact same way. So number 8, find the 5th term only of this expansion. The 5th term. Now, certainly you could write out the whole thing, just like we did this one. What a waste of time that would be. We want only the 5th term in the list. So we need a coefficient. Just like we needed a coefficient for each of these terms. We need a coefficient. The coefficient is going to come from the 8th row of Pascal's triangle. So you have a choice. You've already got it built to the 5th. Go ahead, make the 6th, 7th, 8th. There you go. Or you can remember that the numbers in each row of Pascal's triangle are the combination numbers. So in the 8th row, the first number is 8C8. And the second number is 8C7, 8C6, 8C5, 8C4. So 1, 2, 3, 4, 5, the 5th number, because this question says I want the 5th term, the 5th number in that row is 8C4. So whatever 8C4 is, that is my coefficient. 70. So my coefficient is 70. Next to the 70, I have an x and a 4y. Now I need my powers. Well, if you were writing out the whole thing, the power on x here would be x to the 8th, right? And then 7, 6, 5, 4, so this power is 4. And if that one's a 4, this one is also a 4, because these two have to add up to 8. And then you simplify, so that's 4 to the 4th times 70. That's going to be 17,920 x to the 4th, y to the 4th as your answer. Find the coefficient of the x to the 6th term of 2x plus y to the 13th. Now, by coefficient, we mean this guy right here. Only this one is 2x plus y to the 13th. And we want the term that has x to the 6th in it. So everybody agrees that if we wrote this whole thing out, one of the terms in the list would have an x to the 6th, right? The first term will be x to the 13th. 13, 12, 11, 10, 9, 8, 7, 6. Don't I need the 8th term in that list? Another one I'm shooting for. So I want the 8th term in the list. Alright, so it's just like this one right here. What's the coefficient gonna be if I am in the 13th row and I want the 8th number? Well, I just counted it off. Won't that be 13? 13, 13, 12, 11, 10, 9, 8, 7, 6. Don't I want 13C6? I just counted. It's only the 8th term, right? It is. So I want 13C6. What's my problem? 2x and y. And it's x to the 6th. We already figured that out. And if it's x to the 6th, it'll be y to the 7th. That isn't what we have in this problem. That's what it would be. So I'm going to have 13C6 times, be careful, times 2 to the 6th. So that coefficient is 109, H24, 109,800.
Is it 6 because it's 8C6? Or is it 13C6?
Okay, let me do this one
Counted,
more
right,
time.
right.
I counted.
Yeah, and I thought it ended on 8.
Okay, this would be x to the 13th. Alright, so when I counted down,
Right.
it was the 8th term.
Oh, okay, yeah.
Yeah? Okay. Find the probability of rolling exactly 2 4s in 6 rolls of a die. So you are going to roll your die 6 times, and you want 2 of those to be 4s. Do you care which 2? Like first roll, third roll? No, you don't care. So 6 rolls, we're going to pick 2 of them to be 4s. What is the probability of getting a 4? When you roll a die, 1/6. What's the probability then of not getting a 4? 5/6. How many, this is 4, this is not 4. How many 4s do we want? 2. How many not 4s do we want?
4.
4. Guys, you gotta read the problem. Come on, we're rolling the dies 6 times, if 2 of them are 4s, then the other 4 have to be not 4s. You're doing it 6 times. So whatever that is, all multiplied together, is the answer. Number 11 is exactly the same except a little bigger. Find the probability of guessing more than one right on a 10-question, excuse the spelling, 10-question multiple choice quiz where each answer has 5 choices, so A, B, C, D, E. So wait a minute, what do I want to have happen here? How many do I want to get right? 1 or
2.
oh my, 1 or 2 or, I do not want to do this, because how many questions are there on the quiz? 10? That's a lot. So what would be maybe a better way to do it, Lily?
Oh, I just had a question. If it says more than 1, do you count it in the 1, or if it said 1?
Actually, more than 1 wouldn't count this. More than 1 would start with 2. You're right, Lily, thank you. More than 1 means 2 or more. At least 1 would be 1. I still don't want to do it. That's a lot.
1 minus 0.
So it might be easier to find out the probability of no right answers and the probability of 1 right answer and subtract that from 1. It's still 2 calculations, but that's better than 8 or 9, whatever that is, right? So what's the probability of no right answers? Okay, there's 10 questions, and you are going to get none of them right. So that's 10C0. Pick none to get right. The probability of getting a right answer on this quiz is 1/5. A wrong answer is 4/5, and you want none of these and 10 of those. Anytime you're to the 0, you don't need to include that, because of course anything with 0 is just 1, but it kind of makes it look complete and you put it in, but you certainly don't need it. Or, we're gonna pick 1 to get right. So 10 questions, I'm gonna pick 1 to get right, don't care which one. So 1/5 to the first and 4/5 to the 9th. 1 right, 9 wrong. So I can add those 2 together, and then whatever I get when I add those 2 together, I'm going to subtract that from 1. Because if this is none right and 1 right, then all the rest of it is 2 or more right? Jar 1 contains 3 red and 5 blue. Jar 2 contains 6 red and 2 blue. Find the probability of drawing a red ball if 1 ball is chosen. All right, what's your thought on this? You walk into the room, and there's 2 jars sitting here. And I tell you, you gotta pick a ball out of a jar. What's the first thing you have to decide? What jar? So the first thing you're gonna pick is jar 1 or jar 2, and the probability of each is 1/2. Would you agree? That's it. Now, in jar 1, there are how many balls? 8. So 3 8s are red and 5 8s are blue. Would you agree with that? And in jar 2, we also have red and blue, but we have 6, there's 8 in that one too. That's unfortunate. Okay, there's 8 in that one too. So that's gonna be 6 8s and 2 8s. Whoever put this problem should have not made a match, but oh well, it's fine, we'll just do it. We want the probability of drawing a red ball. So here we go. Probability of getting a red ball out of jar 1 is 3/16. And a red ball, or I should say, or a red ball out of this one is 6/16. I'm not reducing, I'm just keeping the denominator. So the total probability of getting a red ball is 9/16. Would you agree with that? I know what you're thinking, it is because the ball's big. Anyway, just go with it, okay? 9/16. That's the answer to the first question. Second question says, if a blue ball is chosen, what is the probability that it came from jar 1? So what is the probability of jar 1 given that it is blue? So we know we've chosen a blue ball. What is the probability that it came from jar 1? Well, we have a formula for that, if you need it. The formula says, on top, it's gonna be the probability of blue and jar 1. And what's gonna be in the bottom? The probability of blue. Okay, so what's blue and jar 1? Blue and jar 1 would be 5/16. So that's my numerator. What's the total probability of blue? Now, the total probability of red was 9/16. So what would the total probability of blue be? 7/16. So, given that you got a blue ball, the probability it came out of jar 1 is 5/7. A and B are events in sample space S. The probability of A is 0.74. Probability of B is 0.42. And the probability of A and B is 0.32. Alright, here we go. These are probabilities. Got a little overlap in there. That's kind of my clue on a Venn diagram it. That's how I show the overlap. So I know this little section right here is 0.32, which means this over here has to be 0.10, and this has to be 0.42. Is that? Yeah. Now, what do those add up to? All these, what do they add up to? 0.84, which means out here there must be 0.16. So we got people who like apples, people who like bananas, and people who don't like either one. All right, what does this mean? Find the probability that you don't like A, don't have A, aren't in A, but you are in B. So if you're in B but not in A, that must be 0.10. What does this mean?
None.
You're not neither one, so that is 0.16. And then I have my formula for this if I need it. That's the probability of A and B over the probability of B. what's the probability of A and B? They told us 0.32. What's the probability of B? They told us 0.42. And whatever that reduces to, that's your answer.
So one of the last two problems, you're both using conditional probability, right? Then why are they written differently? Like when we did the jar and the B, and then when we did the A and the B. Because you put B as,
Probability of B, or how would be probability?
I don't know.
Or the two events. See, it's
Okay, now this can be written, this is A and B both. So it can be written as B and A or A and B.
oh, it doesn't matter.
It does, no, no. The bottom is whatever you're given. Or when it's written like this, it's whatever you're given. This is A given B. So when we say you're A and B, that's the same as your B and A, right? Yeah. All right, how many 5-card hands from a standard deck contain at least one king? Not doing it because what does at least one king mean? One king or two king, I do not want to do all that. So what is the only kind of hand I don't want? No kings. So what do no kings look like? How many no king cards are there in the deck? 48. 48. C.
0 or 5?
5. It's a 5-card hand, right, with no kings? So what have I done? I've pulled out the kings.
And you subtract.
Now there's only 48 cards left. This will be all the hands with no kings. Agreed? Now, how many hands are there all together? Because I want to take all the hands and then pull out the ones with no kings. So how many are there all together? You do see 5. That's going to be the answer to the question. This is not a probability. This is don't divide. This answer is going to be a number, like 28,362,000 or something. It's going to be a number, right? All right. Finally, Austin's serving percentage is 0.815. If he serves 12 times in the next match, find the probability that he will make at least 11 scores. All right, so Austin's gonna serve 12 times. Right? And we want him, what does at least 11 mean? Here we go again, at least 11, oh, that's all right. At least 11 means 11 or 12, that's okay, I can do that. So he has to get 11 scores or 12 scores. Okay, that's easy. All right, so 12 possibilities, he's gonna score on 11 of them. Or 12 possibilities and he scores on every one of them. Now, every time he serves the ball, one of two things is gonna happen. He's gonna score or he isn't, right? I want 11 scores and 1 not scored. What is my probability of scoring? 0.815. Which means my probability of not scoring is 0.185, isn't it? Now, what if I make all 12 of them? Well, then it's 0.815 to the 12. And if you want to add it in, 0.185 to the 0, because you have no misses. You have 12 scores, no misses. Right? And you're going to add those together. And that's the answer. All right, the quiz ain't going to be that long. We don't have time to do that. But it's going to be problems like that. Some of you need to do a little review. Now, we need to get our notes out because we've got to get started on this next section or we're going to fall hopelessly behind the other classes. All right, a couple definitions to get us started. We are going to look at sequences. And there are basically two main kinds of sequences we're gonna look at. So would somebody give me a sequence of numbers? Shout it out.
1, 2, 3, 4.
Okay, let's pick something other than 1, 2, 3, 4, only because that's kind of like simple. You guys are into the simple, okay, that's all right. You could predict what's coming next in that sequence because you see the pattern. What is the pattern of this sequence?
And
We're going up by 2. So in other words, we're just adding 2. A sequence in which you get from term to term by adding the same number, that's key. Adding the same number is called arithmetic. So what's an arithmetic sequence? It's a sequence in which you get from term to term by adding the same number. Adding the same number. Now remember, you can add positives, which is what we're doing here, but you can also add negatives. So the sequence can be decreasing if you keep adding -3, for example. All right? Now, what about this sequence? That is not arithmetic. What is happening in that sequence? We're multiplying by 2. When you get from term to term by multiplying by the same number, it's geometric. It's called a geometric sequence. So arithmetic sequences, you're getting from term to term by adding, have what we call a common difference. Look, if I take second term minus first term, and third minus second, and fourth minus third, see what happens? That's what it means to be arithmetic. You have a common difference. So in your example, the arithmetic sequence, the common difference is 2. In my problem, look what happens if I put second over first, third over second, fourth over third. This is not a common difference, it's a common ratio. So geometric sequences have a common ratio. The number that you multiply by is your ratio, and that ratio can be positive, negative, whole number, fraction, anything. But as long as the ratio of consecutive terms is the same, it's geometric. As the difference of consecutive terms is the same, it's arithmetic. This happens all the time. We'll have a sequence like this. Let's see if I can do this without this now. Kids will look at, really smart kids, like you guys, will look at it and say, oh, I know what comes next. What comes next? 16, I heard somebody say 16. How are we doing this? What's happening in that sequence? Are we adding? Yeah. Is it arithmetic? No, because the number that we are adding is not the same. Now, is there a definite pattern there? 100%. You could keep this thing going forever if you wanted to, but it is not arithmetic. To be arithmetic or geometric, you have to be adding or multiplying by the same number. Okay, gotta get through number 1 here. A little vocabulary, a little notation. This is called an explicit formula. A sub 1 means the first term. This is the term number. So when we say A sub 1, we mean, okay, what is the first term? Well, if that's a 1, this is also a 1. So the first term is 3 minus 4, or negative 1. What would the second term be? Well, A sub 2 will be 3 minus 4 times 2, or negative 5. And we can skip straight to the 100th term. What's the 100th term? 3 minus 4 times 100, or 397, a negative 397. An explicit formula allows you to generate any term that you want, just by plugging in whatever the term number is. So when I wanted the first term, I plugged in 1. That is vastly different than the second problem. I have asked you for the second term. Now be careful. If you want the second term, don't you have to let n be 1 so that this will say a sub 2? So I'm actually letting n be 1. So my formula will say a sub 2 equals what? If you let n be 1, 3 a sub 1 minus 1? Well, a sub 1 is 2, so 3 times 2 minus 1, that'll be 5. Now the issue with this is, I've asked for the fifth term using that formula. You see the problem? The problem is, to get a sub 5, what would n have to be? To get a sub 5, n is going to have to be 4. So what's the formula say? If n is 4, it's going to say 3 a sub 4 minus 1. Okay, what's the issue?
Would it be 2 times
I don't know
4?
a sub 4. So to find a sub 4, I'm going to have to back up and find a sub 3. And to find a sub 3, I'm going to have to back up and find a sub 2. So this is called recursive. And recursive sequences are built one term at a time. You do something to this term to get this term, and then something to this term to get this term. Now, arithmetic sequences can be recursive. That's what you did here in the beginning, but they also can be for the these are a little bit tricky. All right, that's that. Okay, next time, is that tomorrow? We have a quiz. If you're APing, plan to stay after school. Get her done. Make sure your calculator's up and running, because every problem will require a calculator.